Good afternoon, students. Today we will be studying about third experiment in digital IC applications, that is 328 decoder. In theory, we have studied that SAM for X139 is a 224 decoder, whereas SAM for X138 is a 328 decoder. So, I will go into in detail about the SAM for X138 internal structure of the IC. In this SAM for X138, we will be having three enable pins, G1, G2A, G2B, whereas G2A, G2B are enable low and G1 is enable high. So active high signal, one active high signal, two active low signals in the enable input, and we will be having three inputs, namely A, B, C, and outputs we are having Y0, Y1, Y2, Y3, Y4, Y5, Y6, Y7. So with the selection of A, B, C, any one of the output will be active. So output is also an active low signal. So active low signal means the output will be 0. Output will be, if output is 0, the device is in active state. In active high means if output is 1, the device is in active state. So now for this IC SAM for X138, we have to write the VHDL code. This is the internal structure of the programming. We 328 decoder, where we are using 8, and in AND gates we are using, and also we are using 4 inverters and buffers, 3 buffers. So we are not going to write structural programming, we are only writing data flow programming as well as behavioral programming for 328 decoder. Let us go in detail with how to write a 328 decoder in VHDL. So first of all, we have to study about the truth table. So truth table, if G1 is inactive, regardless of any input you give, X, Y, A, B, C, any input you give, if G1 is inactive, say G1 is active high, so if we have to give 1 only, then only the output, we will be getting the output. But G1 is 0, regardless of you give any input, X-axis, any input, 0 or 1, the output remains inactive, 1. So we are talking about active low signal. So in active low signal, output will be active when we will get the output 0. I have already mentioned you. Active low signals means when the output is 0, then output is active. So if it is 1, it is inactive. Now if you give G1, you may give 0 or 1. If at all, if another enable signal is 1, then also it doesn't care about whether the output is what, because G2A underscore L is active low, so we have to give 0, then only the device will start functioning. The same goes with G2 underscore B. This is active low signal, but we have given 1, so obviously the device will not work. Then when it starts working, when G1 is active high, 1, G2 is active low, and G2B is active low, then from that onwards it will be taking inputs into consideration. Now we have 8 combinations are there. For 0, Y0 underscore L will be active, and rest of the signals, 7 outputs will be inactive. Rest of the 7 outputs will be inactive. For 001 case, 1, Y0 underscore 1 will be active. Y0 underscore L will be active, and rest of the outputs will be inactive. For 010, 2, this Y2 underscore will be active. Rest of the cases. That means here we have to write a code in such a way that G1 should be 1 value, G2 should be 0 value, G3 should be 0 value, then we ANDed it and give it to the decoder, then we can apply the input signals A, B, C. Based on the input selection of the inputs, the one of the output from the 8 outputs, it will be selected. Now if you go with the code of the behavioral style, see what we have written. Library IEEE, use IEEE underscore, dot underscore, logic underscore 1164, this is all common. Now we have taken G1, one of the enable pin in std underscore logic. G2A underscore L, it is active low in std underscore logic. G2B underscore L in std underscore logic. These are all enable pins. Then A is a vector because it is a 3 input. So 3 input, 3 to 8 decoder, no? So 2 down to 0, 3 input vector. Whereas output is 8, Y underscore L, active low, 0 to 7. So Y0 to Y7 will be having, Y0 to Y7 and decoder. Now we will be writing. In the process statement, what we have to write is these 3 enable pins and input A, G1, G2A underscore L, G2B underscore L, we have to write the code. Now here if you write the code, see if G1 and not a G2L, that means not a G2L and not G2L is equal to 1. If G1 and not G2A L underscore and not G2L underscore B is equal to 1. That means enable is 1. If it is enabled, then only it goes into functioning. Then if A implies 0, 0, 0, Y0 will be active. 0, 0, 1, Y2 will be active. So Y1 will be active. 0, 0, 0, 1, 0, Y2 will be active. 0, 1, 1, Y3 will be active. 1, 0, 0, Y4 will be active. 1, 0, 1, Y5 will be active. Because active low signal means if it is 0 only active. 0, 1, 1, 0, so 6, Y6 will be active. Else it will be 1, 1, 1. So this is the code for behavioral style for 3 to 8 decoder. Let us check this code in Xilinx software whether it is functioning properly or not. So here I am copying the code directly. This PPT will be shared with you so that you can cross check it directly and see. So I will be checking whether there are any syntax errors or not, because obviously we have to check for it. So there are no syntax errors. Now next one is I will be going with the simulation. So as the code states, in rest of the state it will be in 111 state. Whatever may be the case, this Y underscore L will be 11. That means all the outputs are inactive. Then here now what will be seen? We will make, see, force constant. This one we have to make 1. Then this one we have to give force constant 0 we have to give. Then we have to give 0. Now here I will be selecting 101. I will be selecting 101. So fifth one should be active. So here you see fifth one is active. Y0, Y1, Y2, Y3, Y4, Y5 is active. We have given 101 is 5. So Wi-Fi is active. This is Y6, Y7. So if you change host constant, if you give 1, 1, 1, then 7th one should be active. See, 7th one, 1, 1, 1, 7th one. That means that 7th bit is active. If you take it, this 7th bit is Y7 is active. Y7 is active. So likewise, if at all, if any one of the here 1, 0, 0, this combination only, the decoder will be going into enable state. If at all by default, by any case, this becomes inactive, then what will be the case? The case is the output remains 1, 1, 1. Nothing will be active. All will be inactive. So this is the code for the decoder for 7x138. Now, the same code can be written in dataflow. The same code with select A as a select. The same code can be written as a in the dataflow. What I am writing the same thing with A as select, which is nothing but input. What we are directly stating 0, 0, 0, why not will be active? 0, this the case will be this when 0, 0, 0. This 1, 0, 1, 1 will be when 0, 0, 1. Likewise, the A as select, we are stating the case with the select lines. This is also data flow. With this also we can write the code and we can execute the state. So I will be sharing the PPT with you so that you have to figure out the behavioral coding and data flow coding, and also we can write the code of the SAMPRX 138 in with the case statement also. So this will be your tutorial program for the lab. I hope you understand it. If you are having any doubts, please comment on the video. Thank you for your patient listening.